Chapter 2, Ace the Security Pillar. Introduction. For a busy person who may not have time to go through the hundreds of pages of the well-architected framework, this guide serves as an abstract of the security pillar of the well-architected framework. Understanding the security pillar will ensure that you are equipped with the knowledge of the best practices of security which you should implement on your workloads in the cloud. The security pillar. The security pillar includes the ability to protect data, systems, and assets to take advantage of cloud technologies to improve your security. As much as one can argue, the security pillar is one of the most important pillars of the well-architected framework. There might be a close competition between the reliability and security. As without security there is no trust with your customer, and without reliability you are not serving your customer. So ultimately it may be up to the organization's goals that which one is to be prioritized. For now, without further ado, let's go through the details of the security pillar. Components. As any of the pillar of the well-architected framework, the security pillar also covers the following two broad areas: design principles, definitions. Design principles. Following the various design principles highlighted in this pillar can help you with securing your applications. 1. Implement a strong identity foundation. You should be able to monitor at every stack level in your environment, and this should enable you to get information about any changes in your environment in as much real time as possible. You also need to have mechanisms in place by which you can automatically take action corresponding to the changes. It could be either a motivation action based on a failed login attempt or a capacity adjustment based on spike in traffic to your application. 2. Enable traceability. You should be able to monitor at every stack level in your environment, and this should enable you to get information about any changes in your environment in as much real time as possible. You also need to have mechanisms in place by which you can automatically take action corresponding to the changes. It could either be a notification action based on a failed login attempt or a capacity adjustment based on spike in traffic to your application. 3. Apply security at all layers. You also need to have security enabled at all stack levels. This can be at the edge network layer with the help of secure VPN or a dedicated fiber connection. At the infrastructure level, you should make use of the Virtual Private Cloud (VPC) and then implement controls at the network ACLs for subnet level and security groups for instance level security. In order to tighten security for your application, you should ensure that the end user does not directly access the instance/OS, but accesses through a load balancer. On top of it, if the application supports, you may make use of SSO to enable application access to prevent the compromise of your environment. 4. Automate security best practices. Instead of using manual processes, your controls should be designed and managed as code or scripts. For example, you should make use of the CloudWatch metric service to generate an alarm based on your predefined thresholds, and then use alarm to notify services such as Lambda to take a custom predefined action as per your security best practices. 5. Protect data in transit and at rest. Depending on the data type, they should be classified into high, medium, or low sensitivity levels. Based on these sensitivity levels, you need to have mechanisms in place encryption the data both in transit, HTTPS/VPN, etc., and at rest, using KMS. You also need to implement access control mechanisms in place which determine who can read the data and who can read, modify, or copy them. 6. Keep people away from data. Another best practice is to eliminate the need of manually accessing the data and, if required, only provide read-only access. You can have these controls in place by using IAM roles. 7. Prepare for security events. Conducting security incident simulations is a valuable exercise for organizations. This is a useful tool to improve how an organization handles security events. These simulations can be tabletop sessions, individualized labs, or full team exercises conducted using simulated environment. Based on learnings or findings from these exercises, you can further strengthen controls according to your organizational requirements. Definitions. AWS outlined 5 focus areas that encompass security in the cloud: IAM, detection, infrastructure protection, data protection, incident response. Let's go into the details of each of them to understand them better and how we can use them to secure our cloud environment. Identity and access management. All infrastructures have measures in place which ensure that you know who users are, you can identify them, and then set appropriate level of authorization. There are a variety of AWS services you can use to enforce this, and these capabilities basically fall into 2 main areas of identity management and permissions management. Identity management. As the name says, it basically identifies the entity which is trying to interact with your environment. The entity can be a human in the form of your administrator, developer, third-party vendor, or end user who is the consumer of your application. It can also be a machine in form of your infrastructure and applications such as EC2 instance, Lambda functions, or an external server sitting outside of AWS. You should follow the below-mentioned best practices for robust identification management. 1. Rely on a centralized identity provider. Imagine you have an employee who has different credentials when accessing different applications across your on-premises AWS services and your application environment. If the employee leaves the organization, it will become such a tedious task to revoke access from all the systems. This is why, for your workforce, you should have a centralized identity provider to manage the user identities in one place. You can integrate your external identity providers, such as OKTA or ADFS, via SAML 2.0 with AWS IAM and enable an authenticated user to access various AWS services. If you have multiple accounts under one AWS organization, you can also make use of AWS Single Sign-On, AWS SSO, and integrate your identity provider with it to enable access to AWS services for your authenticated employee. 2. Leverage user groups and attributes. For both working at scale as well as ease of management, you can make use of user groups to apply a similar set of security restrictions. The user groups are available in AWS SSO as well as IAM user groups. 3. Use strong sign-in mechanisms. You should have a password policy which enforces complex passwords, and this should also be backed by multi-factor authentication. MFA is supported for both IAM users as well as through AWS SSO. 4. Use temporary credentials. Depending on the entity accessing the services, you can use different mechanisms to make them dynamically acquire temporary credentials. Use of temporary credentials take you away from the risk of compromised passwords. For your employees who can make use of AWS SSO or use federation with IAM, if it is a system such as EC2 instance or a Lambda function, then you can make use of IAM roles to provide them with temporary credentials for accessing AWS services and accounts. Depending on your application environment, you may also require your end users to access your AWS resources, for example, S3 bucket for uploads. You can make use of Cognito identity pools for such cases to assign temporary tokens to the consumers of the application. 5. Audit and rotate credentials periodically. Your password policy should have an expiration period which ensures that your users are forced to change the password after a predetermined duration. You can also make use of AWS config rules, which enforce the IAM password policy for rotation of credentials. 6. Store and use secrets securely. All credentials which are non-IAM related, such as databases, should not be stored as plain text or environment variables, but rather you should make use of AWS Secrets Manager to store the passwords. You should also configure IAM restrictions to allow only certain users to be able to use the secrets. Permissions management. 1. Define permission guardrails for your organization. As your workloads grow, you should create multiple accounts to manage them and then use AWS organizations and service control policies to restrict access based on accounts, regions, services, and other conditions. 2. Grant least privilege access. Both users and systems should be granted only the permissions required to do a specific task. This can also be extended by setting up permissions boundaries and attribute-based access controls. 3. Analyze public and cross-account access. If your AWS resources need a cross-account access, that should be done for trusted accounts, which are part of your AWS organization, and you should use resource policies based to restrict actions. A resource should be made public only if absolutely required. 4. Share resources securely. For environments spread across multiple accounts, if you need to share your AWS resources, then you should make use of AWS Resource Access Manager and share resources to only trusted principals from your AWS organization. 5. Reduce permissions continuously. You should periodically use IAM User Access Analyzer and CloudTrail to review unused credentials, users/roles, etc., as well as restrict the permissions attached in IAM policies for all users based on least privileges. 6. Establish emergency access process. Under extreme situations, the access to your workloads may break. In such cases, you should have alternate methods to access your environment by using cross-account roles. Detection. Detection is a critical part of your security readiness as well as action plan. You need both proactive and reactive strategies for security incident detection. Your approach to address detection mechanisms should include both configuration as well as investigation. Let's look at the details of each of the approaches. Configure. 1. Configure service and application logging. You can use services such as AWS CloudTrail, AWS Config, Amazon GuardDuty to record and detect event history, resource configuration changes, and malicious activities across your accounts. For your application traffic, you can use VPC flow logs to analyze patterns and anomalies in the network traffic going within as well as in and out of your VPC. For OS or application-specific logs, you can store CloudWatch Agent on your instances and export logs to CloudWatch logs. 2. Analyze logs, findings, and metrics centrally. Apart from collecting all the logs, you should have mechanisms in place to analyze and identify meaningful information from these to set up benchmarking of good versus bad logs. AWS services such as GuardDuty and Security Hub and aggregate, duplicate, and analyze logs received from other services. These two services alone can help you make sense of the logs received from VPC flow logs, VPC DNS service, CloudTrail, Inspector, Macie, and Firewall Manager. This ensures that you get an overall view of what is happening in your AWS environment and allows you to route, escalate, and manage events or findings. Investigate. 1. Implement actionable security events. Your log configuration and analysis are only useful if you have an action plan or runbook for each type of findings or event. You need to have a documentation about each type of finding and update it continuously with a runbook when a particular event occurs. 2. Automate response to events. Based on predefined or custom pattern of events from various sources, You can use EventBridge to trigger automated workflows, which can either be AWS services or third-party service integration. Similarly, AWS config rules can automatically help you enforce your compliance policy by detecting and parsing changes in the system. Infrastructure protection ensures that the services and systems used in your workload are protected against undetected and unauthorized access and potential vulnerabilities. You can achieve this by protecting networks and protecting compute. Protecting networks. 1. Create network layers. You should have segregation of resources into public and private networks. Only the resources such as internet-facing load balancers should be in public subnets, and rest of the resources, like web servers, RDS, or even managed services like Lambda, should use private subnet to prevent unauthorized access attempts. For large environments with multiple accounts and VPCs, you can use resources like Transit Gateway for the inter-VPC and edge networking. This ensures that your resources are not exposed to the Internet. 2. Control traffic at all layers. Extending the previous point, depending on where you place your resources, you should have control measures in place to allow only specific type of traffic. You can achieve this using network ACLs, NACLs, at the subnet level and security groups at the instance level. Further, you can restrict unnecessary public level from your resources by the means of using VPC endpoints, which allow your instances to access public AWS services using a secure private channel from the VPC. 3. Implement inspection and protection. For the resources which need public access, you should inspect all type of traffic which tries to connect to your resources and have rules in place to protect them from common attacks. This can be done using AWS WAF and Shield Advanced, which can be used in front of your workload resources. 4. Automate network protection. Threats do not wait for the specific time when you are online, and they may impose risk to your resources 24/7. So, you should be prepared to automatically append your security measures based on new sources and threats as well. AWS WAF managed rules along with WAF security automations solutions can help you dynamically block certain traffic based on new and known threats. Protecting compute. 1. Perform vulnerability management. Security vulnerability assessments should be part of your deployment pipelines, and for static production systems. This ensures your code and infrastructure is protected against latest threats. Amazon Inspector can automatically check the common and recent CVEs to which your resources may be exposed. Additionally, you can make use of other methods such as fuzzing to inject malformed data into your application and test bugs. 2. Reduce attack surface. You can reduce the attack surface by removing unused components in your operating systems, be in software packages or applications. The components which you need should follow the best practices for hardening and security guides. 3. Enable people to perform actions at a distance. In order to reduce the risk of human error, you should try to avoid direct access to the systems as resources as much as possible. This includes SSH, RDP, and AWS Management Console access. As an alternative, you can use AWS Systems Managers to run commands in your EC2 instances, or use CloudFormation templates via pipelines to make changes to your infrastructure environment. 4. Implement managed services. Instead of hosting your own resources for database or containers, you can make use of managed services, which take care of the provisioning, availability, as well as security patching of the resources. By using services such as Amazon RDS, ECS, or Lambda, you can get AWS to look after the security aspects of the infrastructure and focus on better things. 5. Validate software integrity. As simple as it may sound, you should ensure that any external code or packages used in your workloads should be from trusted sources, and you should check that they have not been tampered with by verifying checksums and certificates from the original author. 6. Automate compute protection. All the compute protection practices mentioned in this section should be automated to both save time as well as reduce human error. Data protection can be categorized into the following 3 categories described in each of the sections. Data classification. 1. Identify the data within your workload. By determining the scope and sensitivity of your data processes by your workloads, you should classify the data based on sensitivity levels. All security measures for the data protection should be put in place based on the classification. 2. Define data protection controls. Once the data has been classified, you can separate them by tagging them based on classification and use different accounts for sensitive data. The access to such data can also be controlled based on tag condition on the resources in the IAM policies. 3. Define data lifecycle management. Based on legal and business requirements, you should determine the duration for which you need to retain the data. Similarly, the data destruction and access policies should keep the sensitivity of the data in mind. 4. Automate identification and classification. As you constantly add consumable data, you need to have mechanisms in place to automatically identify and classify it. Amazon Macy, which uses machine learning, can automatically discover, classify, and protect sensitive data in AWS. Protecting data at rest. Data protection at rest aims to secure inactive data stored on your block devices, object storage, or databases. Some of the best practices for robust data protection at rest include: 1. Implement secure key management. Encryption of your data at rest can make it unreadable without access to secret keys. However, it is equally important to store, rotate, and manage access control of these secret keys. With the help of services like KMS and Cloud HSM, you can store and manage encryption keys and further integrate them with different AWS services for data access. 2. Enforce encryption at rest. You can configure settings on your resources such as S3 or EC2, which would ensure that the data store is encrypted by default. You can also prevent upload of unencrypted objects to S3 by using custom bucket policies. 3. Enforce access control. You can audit the access to your data at rest by using CloudTrail, as well as service-level logs such as S3 or VPC flow logs. By analyzing the access details, you can put measures in place to prevent unnecessary access, as well as reduce public access as much as possible. 4. Audit the use of encryption keys. If you use KMS to store your encryption keys, then you can analyze the API calls in CloudTrail to analyze the use of the keys over time and determine if the usage follows what you intend to implement for your access control. 5. Use mechanisms to keep people away from data. Instead of giving direct access to data for your users, you should make use of services such as Systems Manager to access the EC2 instances and data in them. Moreover, if instead of handling out raw data directly to the users, you should share reports to them for sensitive information. 6. Automate data at rest protection. By enabling AWS config compliance rules for encryption of data for resources such as EBS, you can ensure automatic data protection at rest in all source resources. Protecting data in transit. Data in transit is any data that is sent from one system to another, and in order to ensure the confidentiality and integrity of the data, it is important to protect it in transit. 1. Implement secure key and certificate management. For all kinds of HTTP-based access, you need to enforce encrypted data transfer by using HTTPS, and for that you can make use of AWS Certificate Manager with supported services such as ALBs, CloudFront, and API gateways. 2. Enforce encryption in transit. You should have rules in place which redirect user requests from HTTP to HTTPS to encrypt the use session with your application. On top of it, you can also have rules and log analysis in place which check and block insecure protocols like HTTP. For data transfer between on-prem and AWS, you can configure VPN to encrypt the data in transit. 3. Authenticate network communications. By using TLS with public endpoints and IPsec with AWS VPN service, you can ensure that there is a mutual authentication in place between the two parties that intend to establish network communication. 4. Automate detection of unintended data access. Services such as GuardDuty can analyze log data received from VPC flow logs, VPC DNS service, etc., and can help determine malicious traffic in your environment. Similarly, you can use S3 Log Analyzer to determine if there are any unintended data access and update your bucket policies accordingly. Incidents response. Despite of all the security measures in place, everything breaks all the time. Your organization should have a process in place which helps you respond to and mitigate the potential impact of security incidents. There are a number of different approaches you can use when addressing incident response. Educate. Educating your workforce about your cloud infrastructure and security measures in place can help them in preparing for incidents in advance. By investing in people and getting them to develop automation and process development skills, your organization can benefit in a long run. Prepare. 1. Identify key personnel and external resources. As one of the first steps to prepare for the incident's response situations is identifications of the service owners internally, as well as external resources such as third-party vendors, AWS support, etc. Your team should have the details of all the resources well in advance to reduce the response time. 2. Develop incident management plans. Your incidents management plan should be created in the form of playbooks with action plans for most likely scenarios for your workload and organization. You can test this action plan with simulations and then further iterate them so that they meet production requirements. 3. Pre-provision access. Your incident responders, who may be part of your on-call teams or operations center, should have sufficient access to be able to investigate quickly and reduce the time during a security event. These credentials should be restricted to only specific personnel and should not be used for day-to-day activities. 4. Pre-deploy tools. Any tools which are needed for investigation purpose should be pre-deployment in your infrastructure. This reduces the time to begin investigation during an event. One of the examples is a package like TCP dump. If there is a security event and your responder needs to take a packet capture, it is useful to have the TCP dump tool installed well in advance on your instances. 5. Prepare forensic capabilities. It is a good idea to have a dedicated system with tools which can enable you to analyze disk images, file systems, and any other artifacts that may be involved in a security event. Simulate. Run game days. Use game days. You gather all your teams together and dedicate them to work on simulated real-life scenarios to test your incident management plans. When you break things in a controlled environment and some plans do not work, it's a good learning for teams to reiterate on their playbooks and be prepared for the real incidents. Iterate. Automate containment and recovery capability. With event use of your playbook, you can codify the repeated tasks to further improve response time. Once your code logic seems to work, you can integrate that directly to the various event sources so that human interaction is minimum in the incident's response. Review based on security pillar. Some of the questions which you will be going through when you review your workload against the security pillar of the well-architected framework are: SEC 1. How do you securely operate your workload? SEC 2. How do you manage identities for people and machines? SEC 3. How do you manage permissions for people and machines? SEC 4. How do you detect and investigate security events? SEC 5. How do you protect your network resources? SEC 6. How do you protect your compute resources? SEC 7. How do you classify your data? SEC 8. How do you protect your data at rest? SEC 9. How do you protect your data in transit? SEC 10. How do you anticipate, respond to, and recover from incidents? The answers to these questions during the review help you identify any gaps in your existing workloads and implement the best practices in your AWS environment.